Good morning, students. Today we are going to deal with next topic from third unit, that is enhancement by point processing. So, regarding this topic, here we are going to see initially we are going to see first what is meant by point processing and what are the different operations that are carried out in point processing. When we say about different point processing, such as we can say negative transform, brightness enhancement, identity transform, log transform, power law transform, contrast switching, thresholding, bit plane slicing. So like this various point processing operations are there that we will be seeing one by one. So first we can say point processing. Point processing. So to say about this, that is processing each and every pixel in an image, we can say it as point processing. Each and every pixel in an image, we will say it as single point or pixel processing. So this see when we are saying about this, it is a direct approach of processing the image. It is a direct approach of processing the image in the spatial domain alone, in the spatial domain itself. So here what is the thing carried out, that is the pixel values are altered based on our requirement with the help of the mathematical operations. So when we are saying about this, it is a primitive method. It is a primitive method. So next we can see one by one the point processing operations. So first we can see negative transform. So negative transform, it is when we want to say about this negative transform, it will just invert. It will invert the input image and it will give an output. So example, in when we are giving the black and white images in input, the transform will invert, and whatever places black is there, it is converted to white, and whatever place white is there, it is converted to black. Like the way interchanging dark for light values and vice versa. The negative transform can be mathematically represented as S is equal to L minus 1 minus R, where there L minus 1 is the maximum number of value in the image. L minus 1 is the maximum number of value in the image, and R is the number of pixels to be inverted. Number of pixels to be inverted. So next we can see brightness enhancement. When we are saying about brightness enhancement, it is shifting of intensity, that is pixel intensity value to higher level. Brightness enhancement. So that when we are seeing about this, here shifting will be carried out in both light and dark pixels. Here both light and dark pixels, the values will be shifted by some constant value. So example, in X-ray images, brightness can be enhanced to find out the darker spots. So this is can say it as brightness enhancements. Here we have given an example. That is when you see here, this is the normal image. This is brightness enhanced image. So when we are seeing the black is seen more and white, everything is very clear. So this we can say it as brightness enhancement. Next is identity transform. Identity transform, that is the same input image is mapped to the output image. The result will be, when we are seeing about this, the input image and output image will be same. In such case, the transformation function, we can call it as identity transform. Say example, copying from one place to another place. So the image should not get altered. So this we can say it as identity transform. Next we can see log transform. Next we can see log transform. This transform is used to expand values of dark pixels and compress values of bright pixels. This transformation used in the place of compression. Directly, if you want to say about this transform is used in the place of compression. So when we are saying about this, it can be expressed as a formula, that is S is equal to C log R plus 1, where S is pixel value of the output image, R is pixel value of the input image, and C is the constant. C is the constant. So next we can see power law transform. This is used for enhancing image for different types of display devices. This transform is helpful for display because each and every display, for example in mobile, in laptop, in computer monitor, in TV, smart, whatever be the device, the display will be of different size and resolution. In such circumstance, to change the images, this transformation is helpful. This transformation can be referred as S is equal to CR power Y. When we see about the meaning of these words in the in the expression, S is the output pixel value, R is the input pixel value, and C and Y are real numbers. Variation in the value of Y varies the enhancement of the images. Variation in the value of Y varies the enhancement of the images. This technique is commonly called as gamma correction. Actually, this we can say, that is, we can say it as gamma correction. Variation in the value of Y, where is the gamma, where is the enhancement of the images. This technique is called as gamma correction. So the utilization area of this transformation is used to for displaying in different monitors, for different display monitors, display images, different intensities and clarity. So this is the thing you want to know about power law transform. Next is contrast switching. Contrast, basically, contrast, if you want to define, it is the difference between intensity values of dark and brighten pixels. Contrast stretching expands the range of intensity levels in the image. Expands the range of intensity levels in an image. It enhances the low contrast images. It enhances the low contrast images. Applying a transform which makes dark portion dark by assigning slope of less than 1 and bright portion brighter by assigning slope of greater than 1. So this is contrast stretching. When we are seeing, this is the way we will stretch. Normally it will be there. Normally it will be like this. When we stretch this, the contrast is changed. The contrast is changed. So next is thresholding. The extreme stretching of contrast yields thresholding. That is the thing. So what is happened in normal contrast stretching? There will be gray colors. Intermediate black is there. Intermediate gray colors will be there. But when we are stretching to the last extreme end, there will not be any gray color and completely it will be changed to black and white. This we can say it as thresholding. Otherwise, it has alternate name also, that is gray level slicing. Gray level slicing function. So if you can define this separately, that is gray level slicing function can either emphasize a group of intensities and diminish all, or it can emphasize group of gray levels and leave the rest alone. This we can say it is thresholding. And finally we can see bit plane slicing. In bit plane slicing, the image is constructed by stack of binary images. So here the images will be differentiated with the correspond to the gray intensity and it is represented as different bit planes. So when here we will, after differentiating this, we will analyze that at certain frequencies the bit planes are not significant, then we can remove that. So in such case we can say it as bit plane slicing. So like this we have come across different bit point based operations in this exam, in this topic. So all these operations are carried out to enhance the image. Thank you.